Hey everybody. Today we're getting some practice doing hypothesis testing for the mean in the situation where the population standard deviation sigma is known to us. The general procedure that we're going to use is this. First, we're going to determine null and alternative hypotheses appropriate to the question that we've got, carefully choosing between a one-sided and two-sided alternative. Then we're going to assume that the null hypothesis is true, finding the z-score of the sample mean that we actually get from our sample data. Using that, we'll compute the p-value of the test, we'll compare p to the significance level alpha, and decide whether to reject the null hypothesis or not. Finally, even though it's not listed here, we're always going to want to try and give a conclusion in ordinary human language, not just saying something about probability. Okay, here's the example we're going to work through. A consumer advocacy group tests the vitamin C content of an organic supplement, which claims to contain an average of 1,000 milligrams of vitamin C per tablet. In a sample of size 32, they find a sample mean X bar of 1,008.9 milligrams. Is the supplement's claim plausible? Assume a population standard deviation of 21 milligrams and test at significance level alpha equals 0.05. So I recommend pausing the video, giving this problem a try before unpausing to see my solution. So this question gives us no reason to think that mu could only lie on one side of the hypothesized value of 1,000 milligrams. Our null hypothesis is going to be that mu is 1,000. We're going to choose a two-sided alternative, mu not equal to 1,000. In this case, it's possible that mu is greater than 1,000 or less than 1,000, and there's no reason that we should only care about one or the other. Next, we compute a z-score for the sample mean that we got. The sample mean was 1,008.9. When the null hypothesis is true, we expect a sample mean of 1,000. So, plugging in, we take the value we got minus the value we expected, and then we divide by the standard deviation of x bar. We know that the standard deviation of x bar is the population standard deviation sigma divided by the square root of n. Overall, the formula for the z-score of x bar is x bar minus mu over sigma divided by the square root of n. When we plug in and compute, we get about 2.40. In other words, the sample mean we got here is about 2.4 standard deviations greater than what we would have expected from a sample of this size when the null hypothesis is true. For a two-sided test, the p-value represents the probability of randomly getting a z-score more extreme than the one observed in either direction. So we observed z equals 2.40, so we need the probability of randomly getting a z-score bigger than 2.40 or less than negative 2.40. The way we're going to do that is by computing the probability on the left. In other words, the probability of randomly getting a z-score less than negative 2.40, and then doubling that. These two areas have to be the same by symmetry. We compute that using technology. I use R, where the command for the standard normal CDF is pnorm. So in this case, to get my p-value, I'm doing pnorm of negative 2.40, and then doubling that. Overall, I get a p-value of 0.0165. This p-value is less than the alpha that we set at the beginning, so we are able to reject the null hypothesis. There is sufficient evidence to conclude that the supplements do not contain 1,000 milligrams of vitamin C on average.